In previous discussions, we have talked about s of t being a position function, and its derivative results in a velocity function, and the second derivative of a position function, or the first derivative of a velocity function, results in an acceleration function. And necessarily from this relationship of derivatives comes the same idea in terms of an integral, that the integral of an acceleration function will equal a velocity function, and the integral of a velocity function will result in a position function. And all of that should follow and make some sense. So if you understand those relationships, then you can see how, depending upon the information that you're starting with, whether it be a position function or an acceleration function or velocity function, and the nature of the question being asked, you might need to consider the issue in terms of derivatives, and you may need to consider the issue in terms of acceleration. One simple example might be something along the lines of, we know that something is shot into the air with an initial velocity of 49 meters per second. And the question is, first, what is its velocity when time is 2? Well, one thing we need to know and just be aware of is that the acceleration of an object due to gravity is always equal to negative 9.8 meters per second squared. So if we were to integrate this, we will end up with the function negative 9.8 t plus some constant c. And what we know is that the velocity when t is 0 is equal to 49. Right, we're told that. And that fact is important because now we're able to solve for the constant, and we can figure out the specific function that we need to consider in this case. Notice that our constant will always end up being our initial velocity. So our velocity function in this case is negative 9.8 t plus 49. And it's plus 49 because the projectile was shot upward. Right? If it was dropped, the initial velocity would be 0. If it was thrown down, the initial velocity would be negative. And now we can answer the question, what was the velocity when t is 2? Its velocity ends up being 29.4. In this case, it would be meters per second. And we're not surprised it's slowing down since gravity is working against it. And all sorts of different questions could be asked with regards to this projectile. But those would be the relationships that we would need to keep track of.